Lesson 9.5 is all about dilations. Now, dilation is kind of a funny word. You've probably heard it used in the sense of pupils being dilated, and it's a very correct use of the term. But really, deep down, a dilation in geometric terms is either shrinking something or blowing something up. So when your pupils dilate, usually they're referring to your pupils enlarging and opening up. Again, that is technically a correct definition of a dilation. But in geometry, it's either enlarging or shrinking down. And we're going to use some specific terminology to go along with it. But here they talk about a transformation with center C and scale factor n for which the following are true. So here's the center, and if we were to take this triangle and we were to dilate it, essentially make it bigger, with the center of that dilation being C, then everything just gets pushed away from C, right? It enlarges, but it enlarges with C being the center. So if C is the center, the image of C is the same thing. It is itself, right? So that the image of C is equal to the pre-image. So that C does not move. And then R, so you have a point R, which is the pre-image, and then the image R is on the line CR, such that if you were to take the length that it was originally, so CR is the original length from C to R, and you multiply it by the scale factor n. So we take this length and we multiply it by the scale factor n. That gives us this new length. So let's say, this length here is 1, and we want to enlarge that by a factor of 4, then that would mean that from C to the image of R is going to be equal to 4. So in this case, they tell us that they actually give us that R to Q is 1, the image of R to the image of Q is 3. So in this case, it's under a dilation with center C of scale factor 3. Instead of, I said 4 before, but this one is actually 3, because we can see the length here is 1, and then afterwards this length on the outside is 3. So essentially if you have a scale factor of 3, it's just blowing it up by a factor of 3, right? If we were to, this is called a dilation, but we would call this an enlargement, right? So an enlargement is a dilation with a scale factor of greater than 1. So our scale factor was 3 in that example before. It got larger, so that is an enlargement. A reduction then is going to be something that has a scale factor of less than 1 but greater than 0, right? We don't really do negatives when it comes to dilation, but only greater than 0, so only positive numbers. But anything between 0 and 1 is going to be a reduction. So if you have a scale factor of 1/3, right, you're taking the size of something and shrinking it down to 1/3 of its original size. If you have a reduction of, a dilation of scale factor 1/2, then that's a reduction. You're cutting the size in half. If you have a dilation with a scale factor of 2, then that's an enlargement. You're doubling the size. So the scale factor is basically just the factor by which the thing is dilated. Those that are greater than 1 we call enlargements. Those that are less than 1 we call reductions. So a few quick examples, and then we'll be wrapped up here. In some cases, we're given some information about some things, and we need to find the scale factor. Here they have a circle with a 3 centimeter diameter and the center C. And then there's a dilation, and you get another circle, B, that now has an 8 centimeter diameter. So they want you to describe the dilation. Well, the fact that they're concentric means that if we draw 2 circles here, let's get 2 circles. We'll get another one here. All right, concentric circles just means that they have the same center. So, one inside of the other, and we could draw a point in there that represents the center of those 2 circles. So concentric, con meaning with, centric meaning center, so they have the same or concordant centers. So since they are concentric, that means that the center that we called C is actually the center of dilation in this case. So the dilation has a center of C. And it says because the diameter of the dilation image is smaller. So circle A with 3 centimeter diameter, and center C is a dilation. So circle A is actually the dilation. Circle B is the original. So you have to watch the wording there. Here it says, this circle A is a dilation of circle B. So A is the one in the center, B is the one on the outside, but B is the pre-image, A is the image. So if it got smaller, that means that the dilation is actually a reduction. Right? It's getting smaller, it's being reduced. And to find the scale factor, we just take even if it's not a circle, you just take a measurement of the dilation, divide by a measurement of the pre-image as long as they're corresponding measurements. In this case, with the circle, the information we're given is diameter. So we take the diameter of the image divided by the diameter of the pre-image, and that gives us our scale factor. So this dilation, the things that we need in order to describe a dilation would be whether it's a reduction or an enlargement, the center of that dilation, and its scale factor. So now they're going to take us the other way. They're going to give us the scale factor, and they want us to make some adjustments and look at what the new image would be. So here it says the scale factor on a museum's floor plan is 1 to 200. The length and width of one wing on the drawing are 8 inches and 6 inches. They want us to find the actual dimensions. Notice in feet and inches. So the scale factor in this case, if the floor plan is obviously smaller than the actual dimensions, so 1 to 200, this has a scale factor of 1 over 200, right? It's going to be less than 1 because the scale floor plan is smaller than the actual dimensions. But in this case, we want to, if we're going from the dimensions of the floor plan to the actual dimensions, we're going to multiply, right? The actual dimensions are 200 times the floor plan dimensions. So we take the one factor of 8, it says the length is 8 and the width is 6, so we take each of these, multiply by 200. But then it does say to give our answer in feet and inches, so we're going to divide by 12 inches to get 133 feet and 4 inches for the length and 100 feet for the width. So the wing measures 133 feet, 4 inches by 100 feet. All right, now moving on with a graph. The easiest way to do this, and I would say probably the only way that we're going to come across in our practice problems and on tests and things like that, is when we have a dilation on a graph, the center tends to be 0, 0, right? It's possible to calculate a dilation where the center is some other point, but it just makes the calculation much more messy. In this case, if the center is 0, 0, we just take the x-coordinate, we take the y-coordinate, we multiply each one by the scale factor, and that gives us the new coordinate for that point. So in this case, they tell us that the scale factor is 0.75. So we're going to take the first point A, and we're going to multiply each of the coordinates by 0.75 to get our new coordinates. Right? Scale factor is 0.75. B, we take each of our coordinates, multiply by 0.75. Same thing for C. Right? So we're going to take the x value, multiply by 0.75, and the y value, multiply by 0.75. And that gives us our dilation. And so our new values, negative 1.5, negative 2.25. For B, we get 0 and 3. Notice this stays 0. If it started at 0, it stays at 0. And then 4.5 and negative 9 for C. So the rule, if you have a scale factor and you're looking at a dilation within a coordinate plane, as long as the center is 0, 0, the center of that dilation is 0, 0, then you just take the scale factor and you multiply by the x, multiply by the y to get your new coordinate. Once you get all of your new coordinates, plot them, and you have your new shape based on the dilation. So quick checks. The first one, they want you to describe it, so you're going to need to find whether it's an enlargement or a reduction. You're going to need to find the scale factor for that dilation as well, and the center. In this case, like I said, in coordinate planes, your center is most likely going to be 0, 0, which it is in this case. I'll give you a little hint. But notice which one is the image and which one is the pre-image. Make sure that you're very aware of that. Quick check 2 is just like the second example we looked at. We have a scale factor. They give us the scale factor and they want us to find, now instead of, when we did the floor plan of the museum, we went from the floor plan to the actual dimension. Now we're going from the actual dimension down to the scale in this case. So it's a little bit different. And then the same thing for 3 follows along directly with the third example, where we are using the center 0, 0 and looking at a dilation on a coordinate plane. So you can follow along with the third example that we did, and we will continue to practice with these in class.